I'm going to talk about Dart. I'm super excited to actually be here at Strange Loop. Kind of walking around the hallways, I feel like the caliber of programmer here that I'm around is really exciting. Being able to give a talk to you guys is a super bonus, but just being here is really awesome. My name's Bob Nystrom, but my sort of online alter ego is Munificent. I was at a talk a couple years ago and had my normal human meat space name on my name tag, and of course no one knows who I am. And then I put my Reddit name on it, and I had a couple of people after that be like, oh, you're that guy, which is weird. So I guess maybe Bob is my alter ego, and this is my real ego. I'm not sure which one. I work for Google. I'm on the Dart team. This is not actually what the Dart team looks like. We have much better gender and ethnic diversity on the team, but we don't look as cool as the 1887 Penn State cricket team. So I figured I'd do that instead. OK, so here's the high-level overview of Dart if you accidentally walked into this room and intended to be somewhere else. Dart's a web language. That puts it in the camp of lots of other high-level languages. It's object-oriented, but it also has a bunch of functional features. It's a dynamic language. The runtime semantics are dynamically typed or dynamically dispatched or duck typed or whatever terminology you prefer there. But it also has an optional static type system. Dart's a web language, but in particular, it's a client-side web language. So it runs in your browser. We have a server-side story too, but the main focus of the team is to be a better language in the browser. And that means the ticket price for being that is that Dart compiles to JavaScript, like CoffeeScript, ClojureScript, lots of other languages. But unlike most other languages in the browser, we also have a native virtual machine for Dart. Makes for a really nice development story. It means you can debug, step through the native Dart code without having to kind of squint through generated code. And then finally, the language is pretty much here. So we're creeping up pretty closely to declaring 1.0. We're using it internally on several projects at Google, none of which I can currently talk about, of course. We've got hundreds of packages of Dart code online on the Dart package manager. There's thousands of Dart repos on GitHub. We're starting to go through the process of creating an open standard for it. So core libraries are pretty stable, language is pretty stable. We're trying to get kind of out of figuring out what we're doing and into we're a real language you can use on production apps. So if this is a normal talk, the next 35 minutes or so would be just kind of a general introduction to Dart syntax and semantics. But I figured I'm very fortunate to have a really sophisticated audience, so I wanted to talk about some more kind of deeper, more interesting ideas behind Dart. But since you guys probably haven't written much Dart code, you need something. So instead of doing a slow, gentle introduction, I'm going to do a really fast one, and I'm just going to run through a bunch of Dart stuff really quick. Just kind of open your mind and let it wash in. So this is hello world in Dart. Function declarations look kind of like C. Execution starts at main. You declare local variables using var. You can declare them at the top level. You'll notice that we're using it after it's being declared. At the top level variables will be lazily evaluated the first time you use it, so the order doesn't matter. Got some nice little string interpolation going on. You can do any expression in there. What else we got? So functions are first class. So here I can barely see the highlighting going on there. There is some highlighting, right? You can see that. So here we're taking a reference to the message function, storing it in a variable, calling it through that variable. When you have first class functions, of course you want anonymous functions. So we have these anonymous functions. Here we're storing it in a variable, so it doesn't look very anonymous. And then for the cases where you have a lambda, an anonymous function where the body's just an expression, we've got some nice little arrow syntax for that. What else? Of course, these are all closures. So here we have this parameter who. We're referring to it in a function. It's declared outside of that function when we return it and later invoke it. The variable's still around. Closures are wonderful. We've got list literals. They look very familiar, very exciting. We have map literals too. Put those together. That means JSON is also valid Dart syntax, which is kind of nice. So I said Dart's an object-oriented language. It's class-based, so every object is an instance of a class. The language has some nice declarative syntax for classes built into it. This is the simplest way to define a class. Add fields to it like this. Unlike a lot of other dynamic languages, fields are explicitly declared in Dart. I don't know if you went to Slava's talk earlier, but he talked about how that helps the implementation optimize things. That part's true, and it's nice. The reason I'm particularly excited about this is it means when you're looking at code, you can reason about the state of an object just by scanning the text. You don't have to see, oh, is some other random code stuffing an extra property on my object that I don't know about? Got constructors. They look kind of familiar if you're coming from something like Java. Also like Java, they look kind of bad. So here we're referencing health 3 times, which is perverse. So we also have some nice syntactic sugar, where here we're initializing the field automatically from the parameter. What other fun stuff? Methods look like functions declared inside a class, because methods are functions declared inside a class. They're called the normal way. We've also got getters. They look like fields when you use them, but their implementation is some computation. And correspondingly, we have setters. These are completely indistinguishable from fields. In fact, in the language semantics, the language doesn't have fields. It just has these magic getters and setters. And the nice thing about that is it means you don't have to speculatively wrap things in getters and setters. You can just make something a field when that's what you need now, and later if you need to do some validation or something, you switch it out to a getter. No one is the wiser. OK, what are some other fun stuff? So we have these little arrows for lambdas. And we thought it would be cool to also be able to use that for named members. So when you're declaring a method or something, if the body's just an expression, you can go ahead and use an arrow there too, which is kind of nice for little one-line members. We've got single inheritance, because the deadly diamond of death is deadly. But of course, classes can implement multiple interfaces. Having to do that manually is sort of a pain. So Dart also has this thing called mixins. They're, I believe, very similar to Ruby mixins and plus or minus similar to traits in Scala. But basically, they give you a way to combine the method sets of multiple classes into your class without the craziness of real multiple inheritance. You still have a single inheritance chain in the result. I would love to talk more about mixins. I think they're really cool. OK, so did I lose you? How many of you? I don't know if the blank faces mean you were lost or the blank faces mean you're like, I totally get it. Did you totally get it? OK, I see thumbs up. This is great. OK, so this is awesome because now I have time left. So for the rest of the talk, I wanted to talk about some kind of more interesting stuff. But languages aren't created in a vacuum, right? So what I thought would be interesting would be to talk about some ideas in Dart, but to talk about them in the context of other languages that have similar ideas. And hopefully I can show some connections or maybe some differences. That sound cool? OK, so here's the way it's going to work. There's some mandatory audience participation here. So we're going to do this like a trivia game. For every other language, you guys are going to have to guess it. So I'll give you some clues, and then as soon as you have an idea, you yell out the answer. This is going to be awesome. It's totally going to work. OK, so language number 1, clue number 1, Lars Bach, the creator of Dart, has also implemented a high-performance virtual machine for this language. The spec was edited by Guy Steele. There you go. OK, so language number 1, Java. So when Java was created, can you see that? Does it look like a star field, a pretty universe? So Java wasn't created in a vacuum, right? Like when the Sun guys created it, there was this looming other language there. And Gosling and company created Java specifically in that context. They created it knowing that C++ was there and sort of as a reaction to C++. And I think there's 2 interesting ideas that Java has that they use to deal with that fact. So here's the first one. So let's say you are James Gosling and you're trying to figure out what Java is going to be, and you need it to be something that will get people using C++ to switch to you. So the obvious idea is you're like, OK, well, I'll just kind of do something value added, right? Like I'll just add a bunch of features to C++, and that's clearly more than C++, so people will use it, right? The hard thing about that is first finding features that C++ doesn't already have. It took surprisingly long to make this slide. But the other problem with that is, like, what's the worst thing about C++? It's too complex, right? So their idea was, what we're going to do is we're going to start with C++ and we're going to subtract stuff. And in fact, the original project name for Java, before it was even Oak, was C++ minus minus plus plus. They were like, we're going to take some stuff away and add a couple of other things too. So here's the stuff they took away. And their idea was, if we simplify things, people will be able to use Java and get stuff done faster. And it turns out there's legit science behind this. So have you guys ever heard of Hick's law, seen Hick's law before? This is a law from psychology, a real empirical scientific law with experiments and stuff. And it relates the number of options a person has to choose from to how long it takes for them to choose that. So here, N is the number of things they're selecting from. Imagine you're at a restaurant, you've got a menu, what do you want to have for dinner? T is how long it takes for you to pick your entree. And B here is some empirical constant that's determined from, experimentation. So the interesting thing here is that there's a positive correlation, right? So the more options you have, the longer it takes you to decide. So the idea with Java was, we'll take a bunch of stuff away from you. So here's a bunch of stuff that you just don't have to spend time thinking about when you're programming in Java compared to C++. And that's cool. That's a win, right? So not only does it take you less time, but also you don't have the opportunity to pick these things wrong, right? Like there's fewer mistakes you can make. OK, so let's talk about Dart. So Dart, also was not created in a vacuum. It's a web language and a client-side web language. So the main kind of language occupying that space is JavaScript. But there's lots of other languages in that space too. I personally think that the web has grown so quickly that there is sort of a partial vacuum in there. Like, the set of things that we're doing on the web is extremely diverse now. So I think there actually is sort of room for lots of languages in here. But when we talk about simplification, that's usually relative to something. So I'll talk about it first in the context of Java, since that's the language we're talking about. So let's see how Dart is a bit simpler than Java. Here's some Java code. Trivia time. How many different kinds of access control are in this example? 4. There's also package private, right? So there's this implicit. So when you're writing Java code, you have to think about, OK, well, what's the level of access I want for each of these members? And then there's verbose syntax required to be able to express all those different options, right? So Dart has some levels of privacy control, but it just has 2. It has public and private. It doesn't have any reserved words for this. Instead, it uses a naming convention. If it starts with an underscore, it's private. Otherwise, it's public. Privacy in Dart is library or module-based. So when something's private, it means it's private to the entire module, not to the class declaring it. And you can have multiple classes in a module. And that lets you do some really interesting patterns that I would totally like to have more time to talk about, but I probably don't. OK, so here's just some kind of, this is sort of a random set of other things that, compared to Java, that you don't really have to think about in Dart. So Java has method overriding, but it also has method overloading. Overriding is dynamically dispatched. Overloading is statically dispatched based on the static types of the parameters. These two features interact with each other. It's a little bit confusing. Dart's a single dispatch language, so it has overriding, but it doesn't have overloading. You just look up the method by name. That is your method. Java, you have classes and interfaces. You need classes because that's where you can implement stuff. But you need interfaces if you want to not use that implementation, if you want to mock things out. So you end up kind of doing both, and you're honestly right back to C++ header files. So in Dart only has class declarations syntactically. But every class gives you a free interface that is the signature of that class. So you can make a concrete class foo, and then you just say, I implement foo, and that means I'm using the interface defined by that class. So you never have to kind of preemptively make these interfaces. In Java, you have that issue of you have to make all your fields private and wrap them in getters and setters because the syntax is different. You may want to go from one to the other later. In Dart, the syntax is the same, so you just do whatever makes sense for your implementation, and you're not locked into anything. Java has arrays and lists. Arrays have a nice syntax. Lists have nice semantics. Would have been nice if they put them together. Dart just has a single growable list built into the language that has all the nice semantics you want and nice literal forms and stuff like that. You've got primitive numbers, primitive values in Java, and then boxed values. There's auto-boxing, unboxing. It's confusing. Dart's a pure object-oriented language. Everything is an object, so everything kind of has the same reference semantics. A bunch of different number types to pick from. Dart just has ints and floats. So that's kind of Java, but it's probably more relevant to compare Dart to JavaScript because that's kind of the domain where Dart's more frequently used. So I'll walk you through one example. So one thing you do writing code, even when you're writing JavaScript code, is kind of define kinds of things, data structures. We can call them classes, but that's a voodoo word for some people in JavaScript. But kinds of stuff, right? JavaScript doesn't have any syntax for that, not yet, not until ES6. So there's patterns, right? So here's one kind of common. This is like the vanilla pattern for defining a monster class in JavaScript. There's other patterns. Some people like to close over the instance state and define the methods on the object. There's some pros and cons there. Maybe you prefer to use a framework. So here, if you're using Dojo, this is how you would make a class. Or maybe here, you're using Prototype. And all of these are fine. Like, there's nothing wrong with any of these. But you have to pick, right? Like, you want to be thinking about monsters, but what you're thinking about is meta-programming a meta-object protocol in JavaScript, right? So with Dart, we just say, here, Dart has classes. If you want to make a monster, this is the way you make a monster. Pretty straightforward. And the nice thing about baking it into the language is we can give you pretty nice syntax for it, too. So it's kind of declarative. So I'll just kind of run through a couple of other sort of hairy corners of JavaScript that we've kind of subtracted out of Dart. JavaScript has a lot of scary implicit conversions. I'm assuming most of you guys have seen Gary Bernhard's Watt talk. It's a lot about that. So in Dart, we don't do any implicit conversions whatsoever. If you have a number and you want it to be a string, you better stringify it. And if you have a string and you want it to be a number, you better parse it. And we don't pretend to know what you want to do. JavaScript has some complex rules for truthiness. If you use some value as the condition in an if expression, which things are truthy and which things are falsy. Things like a list is falsy or truthy unless it's empty, then it's hairy. I should know it better than I do, honestly. In Dart, we just say true is the only true value. Everything else is false. Dart has function scope. It syntactically looks like it has block scope because it inherits it from C. But actually, all of those nested local variable declarations get pushed up to the top level. If you think you're shadowing a variable, you're probably not actually shadowing a variable. And if you think you're closing over a local variable, you may not be closing over the variable you think you are, which is why you end up doing things like ifs, immediately invoked function expressions. So Dart has true lexical block scope. When you do var, that's where the var exists. When you hit the end curly, that var is no longer there. And in fact, in loops, every loop iteration, you'll get a fresh variable there. So if you're closing over your loop variables, they'll do the right thing. This is one of those things where, like, if you've been burned by it, you're like, I'm excited about that. And if you're not, you're like, I don't understand what the guy's talking about. So this is kind of related to function scope. JavaScript has this thing called hoisting, which is that variable and especially function declarations, the declaration of the name gets pushed to the top of the scope, and then the definition stays where it is. That's kind of a hack to let mutual recursion sort of work automatically in JavaScript. You declare two functions, they want to call each other. If we didn't hoist, the first function couldn't see the second one yet. So they do hoisting to kind of get around that. So in Dart, the top level of your program is just declarations, sort of like Java or any kind of static language. And all those declarations are simultaneous, right? So you get mutual recursion and stuff like that, and it just works. And then within the body of that, when you're actually in imperative code land, there's no strange hoisting or playing with your scoping, right? JavaScript it's prototype-based. It has an interesting approach to understanding how methods are associated with objects. It's kind of cool from a language nerd perspective, but it has some weird side effects. And one of them is if you close over this in the body of a method, you don't really close over this. You think you did, and you'll forget, who that method is being called on at some point later. I don't know if that makes sense, but if you've ever seen JavaScript code that says var that equals this, and you're like, I don't get what's going on here, it's working around this. So in Dart actually has a well-defined distinction between a function and a method, and we can bind this when you do a closure in a method, which is super nice. JavaScript's a very imperative language, so when you're defining structures, objects, classes, kinds of types, you're doing it by sort of imperatively poking stuff into a bag of state, right? Dart has a kind of static top-level structure. So when you're declaring a class, you're literally declaring it. You're doing it declaratively. And if you want to sort of mix and match stuff together, we have this mix-in feature, and that's also statically resolved. OK, so that's idea number one, is basically that you can make a language that's more productive for users by actually being simpler than what they had before. This is idea number two. So This is a programmer's brain, right? Looks like a brain. This is your awesome language. So what's the problem here? Problem is your awesome language is not in their brain, right? So like your language has all these cool features, and a lot of the reason to even have those features is just to motivate that brain to be wanting to get it in there, right? But that's really hard. Like think about it. It literally does have to be OCR'd to get it in there, right? Like there's no other way to get it in. So, and it's extra hard because there's usually some other language that you don't like that's already in there. So they're like, why am I motivated to take your language? I already got one. There's a trick you can do. And the trick is you make your language look like the one they already know, right? So when you do that, they don't have to learn your language. They just have to learn your semantics. And your semantics are a lot smaller. So when I spent a lot of time on that animation. I hope you guys appreciate that. So, C came out there, was created primordially. And when C++ came out, they were like, we're going to make it look like C. Java came out, we're going to make it look like C++. JavaScript looks like Java. C# looks like Java. Dart kind of looks like all of these. So for example, if you know C, you can read this program. And this is actually a valid Dart program. If you know Java, you can read this program. It's also Dart. JavaScript, mostly Dart, because we don't have a function keyword, but very close. And it's hard to stress how important this is. So this is the TIOB language popularity index. There are valid methodological flaws with it, but this is like a rough approximation of the most popular languages in the world right now. These are the languages that look kind of like C. So if you're making a language and your goal is to get it into the brains of millions of developers, there's no language choice you can do better than look like C, right? But that does leave you with a conundrum, right? So I've got these two ideas. Take away a bunch of semantics, keep a bunch of syntax. What do you do with the syntax for the semantics that you took away? This is one of the things that I really like about Dart. So this is a bunch of stuff that's valid Dart syntax, right? Valid Java and C too. You've got property accessors, indexers, like subscript operators, infix operators, prefix operators, function calls. So in Dart, semantically, all of these are just regular dynamically dispatched method calls. It's just syntax sugar for a method call with a funny name. So when you're reasoning about that code, you kind of have to know the grammar, but you already know it because C was drilled into your minds at birth. And then the semantics are really easy to reason about. But that doesn't mean, so I think it's great starting with a familiar syntax, but that doesn't mean you have to stop there, right? So the idea is, if you start with a syntax they already know, then when they come to your language, they can already express everything they could express before. They don't have to spend time getting back up to where they were in that other language. But then you can build on top of that, right? You can add more stuff. So I showed you some stuff already, initializing fields more simply, having nice arrow function for defining methods. We've got some more stuff. We've got optional arguments. Here we're passing it, here we aren't. We've got named parameters. You can kind of mix and match which ones you provide. We have this double dot dot is called a cascade operator, which is a way to call a bunch of methods on the same receiver. So here, all of those add calls are on the same buffer object. It's kind of nice. There's some deeper complexity as to why it's nice, but again, I won't go into it, but I would love to talk to you more about it. Okay, so these are the two kind of cool ideas from Java. So number 2, trivia time. Okay, so this language is minimal, been around a while, gets called an assembly language. If only, I don't know if I could even do that. That would be great. C is the right answer. Okay, so does everyone know who this guy is? Who is this guy? Dennis Ritchie. What is his most important contribution? No, inventing Hello World. In order to do that, he also had to create C. So C was based on this language called BCPL, created by Richard Martin at the University of Cambridge in the 1700s. This is University of Cambridge. This is what BCPL looks like if you've never seen it. So it's weird and scary looking, and I don't understand why they say C is based on it, but I guess it is. I'm going to draw your attention to one thing here. I believe these are variable declarations. So compared to C, what's different? There's no types, right? So BCPL is not dynamically typed. You would have to be crazy to design a dynamically typed language in the 60s, right? And it's not type inferred. You would have to be equally crazy. Instead, it's unityped, right? BCPL, yeah, I understand Lisp and ML. BCPL is unityped. It only has one type in the entire language, and that type is a word or a cell or the thing you can fit in a register. So when Richie came along and created C, he's like, I'm going to add types to C. So the question is, what was he doing it for? And we'll do it multiple choice style. Was it A, to prove correctness? We have, Curry-Howard isomorphism. Programming's getting too easy. Maybe we should let people write proofs while they program. That makes it more fun. Catching type errors is good, right? No one likes to ship type errors. Maybe it could be that. Could be to generate faster code. C has a reputation for being one of the fastest languages out there. Maybe that's why. Maybe it's for toolability, all the awesome IDEs of the 60s. It turns out, no, E, none of the above. So let's play pretend. We're going to pretend that we're a compiler, which is a terrible use of your imagination. And imagine that we're compiling this expression A plus B for a PDP. And we've already generated the code to load A and B into registers, and we're sitting on this plus operator, and we're like, what do we do now? Let's see if I can use the little thing. And this is a little bit tricky for us, because we're compiling for this new fancy PDP 1140. And this has a floating point coprocessor. So now we have one of two instructions we could generate here, either an integer add or a floating point add. What do we do? So previous languages, I think B, their kind of cop-out was like, oh, we'll make different operators. But that seemed like kind of a gross choice. So Richie said, well, we'll add types, and then we'll pick the operator based on the types of the operands. So here's a direct quote. I'll read it because reading Richie is awesome. It said, for all these reasons, it seemed that a typing scheme was necessary to cope with characters and byte addressing. Here he's basically describing the same problem but for strings, and to prepare for the coming floating point hardware. So he also understands the value of other stuff too. But the original motivation for C, having a type system, was just so that they knew which machine code to generate. For me, this is the most interesting part of this talk because I didn't know this until I wrote the talk. And I understand C's type system more now. So there's things in C's type system that always seemed weird to me. So like C has type defs, which are pretty cool. And you can imagine using it like, oh, I'm going to type def my int to be this name inches so that I can keep track of my units. And that way I'll get compile errors if I try to cross units. But then C's like, I'll just let you freely convert them, which seems not helpful. Likewise, you can define enums. You'd be like, a color can only be one of these three things. And C is like, oh, you could do a number too. That's fine. And the reason it allows you to do this is because it doesn't need to prohibit this in order to know what machine code to generate. And that's really its intent, OK, so how does this relate to Dart? Dart, I said Dart's a dynamically typed language, which it is. This is valid Dart code. But you can also add type annotations that sparkle when you do. So this is fine. So when you add type annotations, some static typing machinery comes into play. And then the question is, why did we do that, and what value do we think it provides? So option A, to prove correctness. It turns out the answer for Dart that we've chosen is no. Here's my theory on this. So I think there's a triad of type system features. I don't know if you saw Martin Odersky's keynote this morning, but he had like a graph space. I'm just going to do a Venn diagram. So you can have simple type systems. You can have sound type systems in that if there are no type errors at compile time, you are assured that there are no type errors at runtime. Or you can have expressive type systems where if the program is dynamically correct, the type system will let you effectively run that program and it won't prevent you from running it. But my theory is that no one has come up with a type system that's all three. So you only get to pick two. So over here in simple and expressive, you get early Java, you get Go and C, where you have a very simple type system. It fits in your head. It's really nice. Any program you want to write in those languages, you can write it. And you can get the type checker to shut up by just adding some casts. But the downside is you've added some casts, so now you're not really sound anymore. Once you want to be a little stricter, then you get over to Haskell, Java with generics, Scala, C++, where you have these very complicated expressive type systems. And you can be much greater confidence that if it compiles that it's correct, but you lose any hope of simplicity, right? Like no one would claim that those type systems are simple. And if they do, those people are geniuses, and they're not in the same category as programmers like me, so I can't relate to them. So Dart, and then the other one is simple and sound, and it's hard to find languages that fit in this. Pascal was the best thing I could come up with. My theory is that if a programmer knows their program's dynamically correct, they won't suffer a language that prevents them from running it. That's why I think it's slightly less inhabited. So Dart's over here. So we've chosen a language to be simple and expressive. We think simplicity is really important because as a web language, we have to target both people that like type systems and people coming from dynamic languages that aren't really interested in types at all. So their tolerance for type system complexity is very low. And at the same time, we want it to be expressive because they're used to writing dynamic programs that they know do the right thing, and they don't want the type checker to tell them that they're bad and they should feel bad. So the sacrifice we've made is that Dart's type system is not fully sound, right? That doesn't mean it's unsafe like C. You're not going to go into like bad memory land and take down your browser because the runtime semantics are dynamic. It just means that the type system doesn't promise that you won't get a method not found exception. So we're not trying to prove the absence of type errors, but that doesn't mean we're not trying to help you catch them. But we just treat it more like an empirical science. You know, your program has 100 bugs. Maybe you're great. Maybe your program has 2 bugs. If we can help you find 1 at static analysis time, that's great. Like, that's just adding value to your life. We help you find that bug, you fix it, you move on. And if we didn't find all of them, well, if you had no type system, you would have found none of them, so that's still like better than nothing, right? And we think we can actually find a pretty good number of them with a pretty simple type system. We don't use the types to generate faster code. So the DNA of the Dart team is a bunch of VM hackers who've been optimizing dynamic languages since forever. These are people whose names are on the self papers. And they've never felt the need to be statically typed to be fast. But we do care a whole lot about toolability. I say autocomplete here. This is shorthand for all sorts of toolability. So how many of you work on a program regularly that's greater than 10,000 lines of code? Almost all of us. Greater than 100,000? Million? I've worked on stuff longer than 1 million before. Don't know how big it is because it's a mishmash of third-party libraries, some of which you have contributed to and you're not really sure how to draw the boundary. There you go. So you know how when you're new to a code base and anytime you try to do a tiny change, there's this like hour-long discovery process of like walking through call trees and trying to figure out where things are defined, and then you're like, oh, here's my 1 line of code. And then you sort of repeat, and eventually as you learn it more, that gets better. When you're working on a 1 million-line code base, you never leave that mode, right? Like, you're always in discovery mode. You're always exploring the code base. And things like toolability are extremely helpful there. If the software can tell you, here, I know where it was defined, I'll just take you there. If it can tell you, I know every place that's being called, so if you rename it, I can do it safely. So we do think toolability is super important. It's hard to, so the idea here is about simple types, and it was hard for me to come up with the right adjective here. If I was Odersky, I would say cutting corner types, I think, which I think is a slight, there's a value, negative value proposition there. One way I kind of look at Dart's type system is it's kind of like a good roommate in that, like, if you make a mess, it will try to help you clean it up. And it doesn't really ask for much in return. Like, it doesn't put a lot of demands on you. I know that kind of sounds, I don't know if that sounds weaselly, but it's interesting using Dart's type system in practice because even with things like covariance, which is, you know, to many people a terrible thing to just be like, yeah, we'll just make the generics covariant. It turns out in practice, almost all of your usages of generics are dynamically sound in a covariant way. It's really rare that we do things in contravariance. So even a simple type system actually works pretty well. OK, language number 3, the last language. I'll just do this kind of free association style. So I'll just say out words and then whatever comes to mind. So functional, parentheses, persistent. OK, good. That's an easy one. I picked this book randomly just to have some book. I'm not saying that this is the best or worst Clojure book. I haven't read Clojure books. In fact, I know not as much Clojure as I do the other languages in this talk. So if I get stuff wrong, tell me so that I can be less dumb. OK, so let's say we're a web language, client web language. We're trying to write a little web program that gets the labels of all the non-empty buttons on the page and kind of makes a little list out of them. So Dart kind of comes from the imperative C tradition. So you could write it like this. And this is, I think you guys can kind of figure out what's going on here. Query here is the function in the DOM for doing a DOM query. It's like $ in jQuery. We just sort of built it directly into the DOM API. So this is OK, but it's kind of gross, right? Like, it's imperative. There's a lot of mutation. You're explicitly creating a list. You're like if you kind of look at the character count, it's really a lot of the code here is just how it's actually building this list, and not very much of it is sort of what the actual intent behind it is. So here, now if we were to do this in Clojure, we get something like this. This is presumably Clojure script and using DOMI, which I hopefully am doing correctly here. I'm not exactly sure. So here we're doing this, the selector query to get all the buttons. We map them by their text labels, filter out the ones that aren't nil, join them together, and we're done. And to me, this is really beautiful code, right? Like, I feel like it reads like it's showing what my intent is and not what are the mechanical semantics of the underlying language. The only thing that's a little weird is you have to read it bottom up. But Clojure has this nice little, this nice little macro here that lets you kind of pipeline things. So that's really cool. Now, the reason Clojure can do this is because Clojure has two really cool things going for it. It has this Iseq interface protocol abstraction, this thing where any value that can be iterated over, traversed, walked, sequenced, generated supports this protocol. And then there are a very large number of functions that consume and return these Iseqs. There's all these higher order functions that transform them, make new ones, consume them. And these are basically your building blocks for that sort of declarative aggregate collection code. And it turns out in Dart we have pretty much the same thing. So we have an iterable interface. Any object that you can iter over implements this. And that interface defines a very large number of methods, including kind of all the functional transformers greatest hits. We've got map and fold and stuff like that. You may be wondering how much of a pain is it to implement this interface. This is a case where mixins come in handy. There's a mixin that gives you all of these implementations for free in terms of a smaller number of methods. So in your own type, you just mix that in and you're good to go. So if we use this in that Dart example, what you get is this, which is pretty much modulo syntax differences identical to the Clojure code. We're doing the query, we map it by its text, filter out the non-null ones, join them together. And I should stress that this is vanilla Dart code, right? So there's no third-party libraries here. So Dart has its own DOM library, its own core libraries, and we deeply integrated these collections into the DOM library. So like you do a DOM query, you get back something that is a full-featured collection with all of these nice methods on it. Now there's another nice thing going on in the Clojure code and in the Dart code here, which is that all of these transformations are lazy. So I can give you another example. So here's some Dart code, and we're creating an iterable that generates the sequence of numbers from 1 to 10 million. And then we're doing some stuff to it, right? Like we're filtering out the odd ones or filtering in the even ones, mapping them, squaring them. Then we take the first 10, walk it, and print them. And if we were doing this stuff eagerly, obviously this would make your computer sad, right? You don't want to build a giant list of 10 million things and then discard 99% of them. So what it does is like all of these objects are returning these wrapped lazy sequences that only actually invoke these transformations when the very tail end pumps it, when it starts actually pulling stuff out. And that's really nice because it means these generators and these transformations can be computationally expensive. They can have side effects that you want to control. So I think that's really cool. I've got some. I should have used the highlighting while I was talking, but I didn't. So I think laziness is nice here, but there's kind of like there's more lazy than lazy, right? And the thing that's more lazy than lazy is asynchrony. And we have something really cool here. I kind of jammed this in at the last minute, so hopefully I'm OK on time. So how many of you guys saw Rich Hickey's keynote about channels? It was a great talk, right? So Dart has this class called stream, and it's 80% semantically similar to his idea of channels, where it is a asynchronous producer-consumer of values. So you can put values into a stream if you have the controller for it, and then you can read values out of the stream, and this all happens asynchronously. But on top of that, we added the exact same higher order functions that the normal iterable interface has. So you can map and filter and all this stuff, and now you're doing the same operations, but you're doing them asynchronously, and you get a new asynchronous stream in return. And what's really exciting about this, so towards the end of Rich's talk, he said, OK, here's this beautiful world we've created, but over here's the DOM, and there's a certain amount of like duct tape involved going from event handling land to nice channel land. But with Dart, we control the DOM API, and this is in our core library. So what we did is we just made the actual event handlers be streams. So when you get a button and you look at its mouse down event, that event is a stream of mouse events. And that means you can filter it out, map it, listen to it, create new streams in response to it. So here, this is going to print every time you shift click, it's going to print where you clicked it. And I really like code like this. I get excited by this kind of stuff. OK, so, and again, I will stress that this is vanilla Dart code. So the kind of, it's hard to figure out how to encapsulate this, but the idea that I'm going for here is that if your system has powerful collections and powerful ways to sort of transform and modify those, I think that's just a huge performance, not productivity boost for everyone using your language. And it's particularly important for collections and in the core libraries because it means all third-party code can interoperate with these. So I don't have to get a dumb list from some third-party library, wrap it in my nice list that uses an API I really like. You sort of get the nice list immediately, right? Because we're all agreeing on that. So these are the 4 ideas that I kind of wanted to run through. This is sort of my list of stuff that I think was interesting about Dart, that it has, I think, a simpler semantics compared to some other web languages, or in particular languages that just have longer histories and accumulated more cruft. But at the same time, it has a pretty familiar, approachable syntax. It has a neat kind of simple type system that tries to help you as much as it can without forcing you to do a lot of theorem proving and kind of work. And then it has a really, really nice standard library that, for me, is sort of a joy to use. So when I wrote this talk, I got to the slide, and I was like, OK, here's the summary. But I feel like it misses the kind of the feel of what it's like to use a language. And it's strange being in my position where I talk to people that haven't used Dart, and they're like, well, what's Dart like? And it's like, it's one of those things that just doesn't seem to transfer very well across people. So this is kind of my sort of attempt to describe like how Dart feels to me. A lot of my programming history is in object-oriented languages. I've written lots of C++ and Java, and like I really like classes. I like objects. I like, especially at the macro level, organizing my programs in terms of like objects that interact with each other. Like it feels natural to me. I understand that like at Strange Loop, maybe this is a heretical statement, but like this is a comfortable way for me to organize code. And I like the idea of sort of, classes as being kind of a unit of modularity. But at the same time, I'm really comfortable with a lot of functional features. I like closures. I like higher order functions. I really like not having to use classes for things that aren't stateful. Like sometimes all you need is a function, right? And my experience writing Dart is that it's one of the few languages I've used that feels like it does both of these on pretty equal footing. Like I've tried F# and I've tried other languages that sort of try to be multi-paradigm, and they usually kind of feel like they're sort of bolted together, Whereas Dart, if I write Dart code that doesn't create any classes, it feels like legit Dart code to me. And if I write Dart code that has lots of classes, like that's legit Dart code too. And that makes it for me kind of a fun language to use. So if any of that sounds fun to you, I would highly encourage you to check out dartlang.org. We have lots of fun stuff here. We've got documentation. We've got a language spec. Specs are nice. People like language specs written by Gilad Bracha, famous language spec guy. Got some tutorials. We've got a bunch of sample code. Starts a web language, so the samples run in your browser, which is kind of neat. We've got an entire book, which is kind of cool. That's you can also just get for free from the site. And as a language nerd, kind of the coolest thing is we have try.dartlang.org, which lets you just compile Dart code in your browser. And the way it works is our Dart to JavaScript compiler is written in Dart. So we compiled it with itself to JavaScript, stuck it in a web page, and now you can kind of just try out Dart on the web, which is pretty cool. And that's it. So I have no idea how I'm doing on time. When am I supposed to be done?
You're over by 4.
Over by 4. I'm very sorry for whoever is coming after me. If you have questions and would like to talk to me, I would love to talk to you. So just come bug me at any point in time. Thank you.